Merhaba everyone. I'm going to be working example problem 6-7, the heating of a home by a Carnot heat pump. So this is on page 306 using figure 652. Okay, so example 6-7, heating a home using a Carnot heat pump. So for this problem, a heat pump is used to heat a home to 21 degrees Celsius during winter. Heat pump is used to heat a home to 21 degrees Celsius during winter. The home loses heat at a rate of 135,000 kilojoules per hour. Loses heat at 135,000 kilojoules per hour when outside temp is -5 degrees Celsius. Determine the minimum power required to drive this heat pump. Determine the minimum power So if this pump was operating at its maximum efficiency, if this was a Carnot heat pump, what would be the minimum amount of power that's required? So for this problem, our assumptions, we're going to assume this is a steady operating condition. Steady operating condition. So our Q sub H is going to be 135,000 kilojoules per hour. And in terms of modeling this problem, here we're going to have our heat pump, where it's going to be going to our home, heating up our home from our outside air. Outside. So outside is going to have a temperature of -5 degrees Celsius. Inside the house here is going to have a temperature of 21 degrees Celsius. We're going to have our rate of heat transfer from our lower temperature, our rate of heat transfer from our higher temperature. And we also have that the house is losing heat at a rate of 135,000 kilojoules per hour. And we're trying to figure out what is our work net in, our minimum work net in. Okay, so sorry, it's kind of small. We have our heat pump that's heating up the house. The house is going to be at 21 degrees Celsius. Outside is -5 degrees. We're putting power into this heat pump, and the house is losing heat at this rate. All right, so first, we want to know the heat pump must supply heat to the house at the rate that it's losing heat. So in order to maintain this 21 degrees Celsius at steady operating conditions, we need to be compensating for this heat loss. So this heat loss here, our rate of heat transfer out of the home, is going to be from our higher temperature, and we know that it's 135,000 kilojoules per hour. So we need to offset this heat loss to maintain this temperature inside the house. So I'm going to convert this to kilowatts. We know that kilowatts are kilojoules per second. So I know that in 1 hour, I have 3,600 seconds, which makes this 37.5 kilowatts of heat loss power. And then I want to figure out the power that I have to put in to offset this power that I'm putting out. And the way that I'm going to do that is by looking at the coefficient of performance. So coefficient of performance for my heat pump. And I'm assuming here that I'm at the maximum efficiency. So I'm going to assume I'm a Carnot heat pump. I'm at a reversible heat pump. This equation, if you recall, 1 minus TL over TH. And I know my outside temperature, I know my temperature inside the house, so I can get my coefficient of performance for my reversible heat pump. 1 over 1 minus -5 over 21. In the problem, it converts it to Kelvin. So you add 273 Kelvin. Kelvin is now our temperature. And this gives you a ratio of 11.3 is our coefficient of performance for a reversible heat pump. And so now I have my heat loss, I have my coefficient of performance, and I'm going to use my equation for work net in, which is what I'm trying to solve for. This is what I'm solving for. So I know that my equation here is going to be my loss of heat divided by my coefficient of performance of my heat pump. So I was given my heat loss. I just solved for my coefficient of performance. If it helps you to start thinking about what you're solving for, getting this equation, and then figuring out how to solve these, that's a totally fine way of working the problem. Figure out how it works for you to think about how to solve the problem. All right, so we know that we have 37.5 kilowatts and our coefficient of performance is 11.3. This is unitless, it's just a coefficient. So this is gonna give us units of kilowatt, and this gives us roughly 3.3 kilowatts. So our required minimum power, so we're gonna require more power than this because reversible heat pumps don't exist. This is an idealized pump. This is our minimum power requirement. To keep a house at 21 degrees Celsius when it's -5 degrees outside at this rate of heat loss. We need 3.3 kilojoules per second. Okay, so that's problem 6-7, heating of a house with a Carnot heat pump. This is on page 306. I encourage you to look at the discussion associated with this problem to make sure that you fully understand why we are solving for power like this, all of the nomenclature, everything. So with that, I will see you in future example problems. Have a good day. Bye.